from our favorite artist electronist, Mr. Q12. Alright, welcome to the second part of the ADC0808. I did some significant corrections to the both to the circuit, to the electronic circuit, and to the code as well, because I had to adapt the code to the circuit that I had here. A friend of mine, an English guy from UK, he is having ADC0816 instead of 08. He has two of them from a very long time ago. And I have 0808. Well, it will come in the postage. I don't have it right now in my hand, but it will arrive very soon. 20 of them actually. I made a mistake and I bought another 10 of them. And I have 0832. So he is having the in between what I have. These two values, 0808, the 08 and 32, he is having 16. And the datasheet of the 16 is saying, and the chip itself is pretty similar with this 08 that I'm having here. The exception is the number of input pins he is having. That 16 is having 16 inputs instead of 8 inputs that this chip is having here. But other than that, also is having some other additional pins that you can do some other stuff with them. So it's a bit more advanced, a little bit more advanced than 08 chip that I'm having here. But the code should have worked on his chip. The code that I write here for this 08, it should have been worked on his chip, but it didn't. And I did assist him, and I couldn't figure it out. But from that experiment, from that experience with his chip, I decided actually to put all the 8 lines, to connect all the 8 lines to the Arduino board, as you can see here. Let me select them if I can. Yes. So these are all the 8 lines to all the pins, 8 pins, digital pins of the Arduino. So I've added this 9, 8, 7, and 6. This last 4 lines. Also, I had to add it in code as well. This is declaring the inputs here. He wanted very, very important. Let me actually, because I did write it down what I did in this version, in version 4, which we are looking right now here, or at least the title here to actually be clear what version it is. So this is version 4, where I modified some stuff. The code is using interrupt function correctly. So I managed to make the code use the interruption correctly. Well, in a previous version, the one with the 4 lines, I managed to make it. But yeah, well, I included it here because I kind of overwrite this save file and I've added the rest of the electronics wires. Then I removed the 7493 binary counting, which are this entire circuit that was counting to 5 in binary, that was linked to these address pins, address A, address B, and address C, to these pins, and replace it with address cycling from code. So I'm cycling through all these addresses directly from the code. So this is setting the address. I made a custom function and is reading these pins here. Well, not those pins, the pins of the Arduino, 3, 4, and 5, and you can see it here, 3, 4, and 5. And this is linked, but imagine that is linked. This wire here is linked under the board, like it's an electronic board, and this is like a via underneath it, so you cannot see the track. And it's very handy, and I'm using it sometimes. This shortcut, I'm not using it all the time, but it's very handy at some points in your electronic diagram that you have. So I link them like this, without a physical wire, a clear physical wire. Yeah, you get it. Okay, so next, linked all the 8 outputs from ADC0808 to 8 pins on Arduino. So I already mentioned this, all of these pins. These are the major changes that I made from the previous file that I had. Let me explain the code a little bit, because it is interesting. So this is how I imagine. This was in my imagination how I should make this function look and feel. When I'm setting 111, I will actually transmit this data that I'm setting here directly to the address pins. And this add3 is taking this value that you are changing it in code, and this is how you are using how I am using the function. I'm setting the values, the address values, pretty much. And here in the actual function, in the internals of the function, they are going directly to the respective pins of the Arduino, and sending further to the chip, to the ADC chip. All right. So and here I made incAddr is a shortcut for increment address. So I'm incrementing the address one by one, and if this variable, this integer is a simple integer, which is global. In this case, is a global variable here outside of the function, and when this variable is equal to 0, it will set this address to 000, to all these pins 000. And when it will get to 7, it will make this 1111. So the function is moving line by line like this, and nothing will. If all of these ifs are not correct, they are all false, they will not execute anything, and this will increment every time it will pass through it. It will increment, it will add +1, and if is over the value, when it will reach 8, it will reset to 0 and start again, and it will do the same thing. It's an automatic. This is an automatic function that is used. Where are you? Here it is. So inside this void int0 for the use for interruption, I'm using So that's it. This is incrementing automatically, and I don't care how he's doing it. I know how he's doing it because I created it. But when I'm reading this code inside this function, this little function inside it, I don't care what it's doing. I know for sure it is incrementing it, incrementing the addresses, and it's doing it absolutely perfectly. And then I've added this little jewelry piece of code, add space to blocks. So I made this. It was a little bit of code here. This code. It was this code. This code was here, and it was adding too much to the general code feeling. I included it in its own function to be very quickly to toggle it on and off by commenting it out, like that. That's the whole reason I made this this little code that I put it into its own function, just to be able to comment it out very quickly for test purposes, of course, and for convenience, for coding convenience, to toggle it on or off when I please. So let's toggle it out right now. So now it will be available. It will function. Oops. Oh, yeah, I forget that to comment that. I'm changing the names, and I have to. 1 second. I have to change it also here in my actual backup, but I'm having it. That's it. All right. And let's run the code. Actually, now it's not doing anything. I'm doing it manually from here. Yes, only the first bits are doubled, but the rest will function absolutely fine. And also the LEDs are in synchronicity. I believe this is another thing that I did, but I didn't mention it here, and I almost forget it. So this is another thing that I did. I reordered the 8 input bits from code to match the LED's output display. Where are you? Yes, here it is. So this part I reordered. Before it was starting with 13, 12, 11, and 10. And by reordering the numbering, I matched the displaying of these LEDs that I'm having here. So that's very interesting and very important, because right now at this moment 111 represent 1110 represent exactly what you are seeing on the LEDs display here, 111 and 0. You see? And let's cycle to the next one. You see, 1001, 1001, and 0100, 0100. Of course, this was made only for 4 bits originally when I made all these changes. So when everything is 111, everything is 111 as well here, but also is including that space between them. Remember this? Where are you? Yeah, here it is. This line. So now let me comment it out. You see how simple and how easy you get rid of a function to actually make it as you please, pretty much. So saving and verifying, compiling it actually. I have to stop this, and when I'm playing it again, now all the bits all the lines will not have, after 111, will not have that space. And let me leave it on automatic mode, and you see it's now I pause it, and now it's one after another. Very, very cool, very, very nice. I really like it. So that's the code that I changed. And believe it or not, I made another important change, very important change in the entire circuit. And believe it or not, the same code is working for that as well. Absolutely, I don't have to change anything in the code here, but the electronic circuit is considerably changed. You will see in a second. So now we will get, I will put this was version 4. So I'll put this down, and let me drag this here to actually see that it is the next version. So by comparison, to have them side by side, do you see how these are pointing from plus 5 volts? The current is passing through the LED and through the pin of the chip and going and surging through the negative rail. But this time I reverse it. So that was the entire the entire intention. My full intention was to flip all the LEDs to receive the positive, to sourcing from the chip pin. The current is sourcing through the LED and is surging to the ground there. So I flipped the entire logic of the LEDs of the output pretty much. But by doing that, a little bit of correction there. But by doing that, I had to also get rid of these not gates. So I get rid of them. As you can see, there are no not gates. So I greatly simplify the circuit right now at this point. And the only reason, let me actually open the file, because save it, yes. And let me actually open the file because I put some notes. I've written some notes for myself, of course. So the code is the same as it was before, no changes. So when I'm saying the code, I mean this code, exactly the same code. I'm using it in both of these versions of the circuit of the ADC0808. So the code is running for both of them, okay? But we will concentrate on version 5 right now. So the code is the same as it was before, no changes. Okay, good enough. I'm very happy with it. I removed the nuts on the outputs of the on the outputs of the ADC0808. Okay, to be a bit more clear, I inverse the LEDs on the outputs of and link them to ground. So it's exactly what I just explained until now. I inverse them, as you see. And then I realized it's a very big problem with the pots, the potentiometers. So originally, this line, the 99% of the pot represented a 1% on the LED display here, on the LED display, and on the terminal. But then I realized maybe if I will flip the component. So by flipping, I mean this X mirror. So when you X mirror it, let me grab it, copy, and paste it. So by mirroring, you are doing it like this. You see, it flipped on the other side. So this side is to positive now, but it was to negative. So pretty much I inversed the component. That's it. And by realizing that by flipping the component, I was actually guessing maybe if I will flip. I wasn't sure, but I was guessing maybe if I will flip the component, maybe it will work. And it did. It did absolutely perfectly. So I inverse the pots, I flip them, X mirror them. Everything is back to normal. And yes, it was a mistake from the very beginning, and I didn't say it because I was preoccupied I was distracted by other problems, bigger problems that I had. The interrupt pin in the code, how to link the ADC chip to the Arduino board. Those were very important problems, and I really couldn't think through clearly this little shitty detail with the flipping of the component. And yeah, it was a very important mistake, but I did find solutions. I did find solutions by adding these knots here and inverting the LEDs until but this was very important. If I was making it correctly, flipping it correctly from the beginning, I didn't have to add all this crap that I'm having here, but it worked. That's all it matters. So now we are back in business, meaning that this is a more perfected circuit diagram, a more serious and a better circuit diagram than I had in the first video that I ran it, that I filmed it. So let's play it and let's see if it's doing what I'm saying is doing. So as you see, 1 0 0 0 0 1 on the other byte here, and yeah, the first two lines are double, but the rest are fine. So but now what I'm telling you to concentrate to is the order of the bits and how correct they are. As you can see, let me actually use my so as you can see, 3 of them. You see, if I'm separating it like this, 1 2 3 and 0, so 1 1 1 and 0 is exactly what we have here. 1 1 1 and 0, and then a 1 here and 0 0 0, and exactly what we are having here. So absolutely gorgeously, I love it. And the next it will be yeah, this one, and next 0 0 0. Before it was 1 1 1s, but now because it's surging directly to the ground is 0 0 0, as it should have been from the very beginning, but it didn't. That 1 1 1 version is actually very interesting to have because it will signal you that it is working. While having 0 0 0, you are not really sure if it's working or not. you know what I mean. If you try these things, sometimes it's giving you false positive. That's the term. You believe it's working, but actually it's not working. So having them all to 0 0 0 to off is not really good, but good for testings at least. It was better to have them all on all the LEDs. They helped me quite a lot in that building, how I build them. So this is it. And of course, if I'm switching to automatic, it will do its business. And also, let me stop it. Let's change the code. Let's add that space between the 111s. You see, this is the code for the 111s here. So this is the line. So right now, it will add that weird space. In this case, it will be weird because I'm testing. But in the very end, when every input will be linked to a potentiometer, so all 8 pins will be used, then this 1111 will be very good to have, and this space will work as it should be. But now it's adding a little bit of it's not nice. It's not nice. So let me compile it. All right. Now I compile it. Now when I'm running it, switch it to automatic, and it didn't. Why? Motherfucker. Unbelievable. Shit fuck. Why the fuck are you? Oh shit! It's not 111. It's 0 0 0 0. No, so it's not actually working from here to here because I changed the rules. Okay. Unbelievable. So now I should do this. Stupid me. I should do this. So 1 2 3 4 change. So I included 8 of 0 0 0. Save. Now when I'm verifying, that's the only. Now it will add that space. You see that space, and let me pause it from there. And as you can see, after the 0 0, it will add the other stuff. I can make it bigger like this, easier to see. And yes, that's it. Absolutely gorgeously, absolutely awesome. I didn't realize this 0 0 0 before the movie. Right now, actually, I managed to find the problem. But yes. So this is it about this quite important update in which I simplified the circuit diagram, and I've added some very interesting code that is automating the flow of the code. Pretty much is making it automated. So yeah, I'm pretty proud of the code. Oh, another thing, very important thing actually. I was discussing with my friends from Arduino forums, and my friend from Arduino forums said about this function that I'm using it, which was int0. This int0 that is used for the interrupt function is used here in the interrupt function. This from his explanation, yeah. Therefore, interrupt function should consume only a minimum of time. I knew that. I swear to God, I knew that. But I know that this interrupt should use very small and very direct code inside it. But I use it as I'm using it here anyway because of testing things, and it should be like updating. He is actually saying this like updating a single variable. Let me read it for you. Usually only let me actually read it all all what he wrote here. I can make it bigger. So get that you solve this the issue on your own. That's mostly the best solution because it helps for further challenges, of course. However, are some things you should consider when using interrupts in the future. So that's interesting. It is not recommended to use serial print functions in an interrupt. The reason is that interrupts do not only interrupt the usual loop business, but also stops further functions which are of vital interest for overall functionality. Yeah, I kind of understand it. Therefore, interrupt functions should consume only a minimum of time. So this is very important. This line is very, very important. And I totally neglected it, but I was testing. My excuse is that I tested the thing and I was learning it. And also this guy, who is extremely helpful, he did hint me on the right direction all the time. But the tests he made on something weird that is completely different from my Proteus simulator that I'm having here. So let's continue. Usually only time critical parts are done in an interrupt. You see, time critical parts, like retrieving data from an external port or setting some flags. What it means by flags, it means some variables that tells the application to run in loop that something has happened. Serial is definitely not one of the tasks to be called in an ESR, interrupt service routine. Okay, I believe him. I really believe this guy what he's saying here. If variables, number 2 point here, point number 2, if variables are changed in an ESR, it may be done while the loop application also tries to read or modify it. This may lead to unexpected behavior or errors, especially when the data type is longer than 1 byte. You may read this interesting link, and also there. The keyword volatile is often suggested together with interrupts, but it is more relevant for the use with hardware registers or ports that change their data driven by external functions. No interrupts or interrupts should be sufficient in a loop applications outside of an ISR to ensure proper reading setting of variable shared between loop and an ISR. Yeah, well, this is more technical, very, very technical explanation. And what he is actually saying here, that I should use this volatile and to expect errors, even if I'm using correctly this ISR. Some types of data, especially if they are bytes with multiple, or probably with what I'm doing here, but to expect errors, even if it's functioning, even if it's used absolutely correctly, it will still throw some unexpected errors, probably from longer, from very long stream of data. And what he is referring to, the incoming data that is this function is reading, that is handling that data. If it's very long data, it will probably get messed up at some point if the timing is too quick, if you are changing it. Exactly, most probably like my error that I created it, you know, when I'm switching this switch, you see, I'm adding to the error, I'm creating the error. This switch is not really meant to be switched like that, you know. And yeah, probably most probably that's what he is referring to. But this is it about, so yeah, this is it about these little details. And yeah, I'm very curious how my friend ADC will work. Yes, this is it for this part. Thank you very much for watching. I hope you like it, and see you later from the best artist electronist on the world, Mr. Q12. Alright, bye bye, see you later.